Yes, good morning. Today we're going to talk about Math 111 in sections 5.5 in our book entitled Gcf Factoring. Of course, we probably all know the Gcf stands for Greatest Common Factor. Alright, let's jump right to it. Factor the following expression. 2x plus 4, and I'm confident everyone here in our class could handle this, even without telling you what factoring is. You've probably been doing factoring of this type since your first course in algebra years ago. Factor 2x plus 4. Well, we have to spot the GCF. What is the greatest common factor? What is the greatest quantity that is a factor, meaning an element of a product of these two terms? Well, of course, it's 2. So if 2 is a common factor across a sum, I can really work my distributive law in reverse and factor out, as some say, the GCF of 2. Notice, if I go in a left to right direction here, I am factoring. Basically, I'm rewriting a sum of terms as a product of factors, hence the verb to factor, or the act of factoring. If I go in reverse, I'm really multiplying. So you can always check your answer in a factoring type problem by multiplying. I don't insist that you check each and every problem, but certainly on some of the sticky ones you might want to. Alright, let me write down what factoring is to equivalently rewrite a sum of terms, typically a polynomial, as a product of factors. Now recall, a factor is an element of a product. Right? So hence the verb to factor, or the act of factoring. Alright, let's get right to it. Factor the following expression. 16y squared plus 24y. Alright, well, GCF factoring is one of several types of factoring we're going to cover in this chapter 5. To do a GCF factoring, well, you've got to look for a GCF. Look for a greatest common factor. What is the greatest quantity that's a factor that's embedded in both terms of this sum? Well, I think I spot a, well, let's see, 8y. I think I see a factor of 8 and a factor of y in both of those terms. And if I do, I can really work my distributive law in reverse and rewrite this expression as a product. Alright, if I factor out an 8y, well, what's left in this slot? It's a 2y, is it not? And if I factor out an 8y from this second term in the expression, I'm left with a 3. Alright, so I have factored. I have rewritten a sum of terms as a product of factors. Again, if you want to check, that's fine. 8y times 2y is 16y squared, plus 8y times 3 is plus 24y. Alright, let's jump to the next one. Factor. Factor the following expression. This one looks a little nastier. 25a cubed b minus 15ab cubed. Well, let's see, can we spot the greatest common factor? Certainly, both of these coefficients are multiples of 5. That makes me think 5 is going to be part of a GCF. Both terms contain at least one factor of a, and both terms contain at least one factor of b. So that means I'm going to be able to factor out the GCF of 5ab. What's left inside? Well, let's see. I believe it's 5a squared is left in this first slot, minus 3b squared in the second slot. All right, let me rewrite this. 5ab times 5a squared minus 3b squared. Again, we can always check our answer. 5ab times 5a squared is going to be 25ab cubed. That checks, right? Or I'm sorry. 5ab times 5a squared will be 25a cubed b, so that checks. Similarly, 5ab times 3b squared, there's a b in here by the way, is going to be 15ab cubed, so that checks out too. So there's my final answer, a factored product, right? Try another one. Factor. Go back to yellow. And this one looks a little nasty. 3xy squared z cubed plus 6xyz cubed plus 3xz squared. Alright, I usually take a look at the coefficients first, see if I can spot a GCF, a meaningful GCF of any of these coefficients. And of course, a factor of 3 is embedded in all 3 of those coefficients. I've got one factor of x in each of those 3 terms, so I can factor out an x. I've got, well, let's see, I've got one, no, I don't have any, this term doesn't have any y's. Now, greatest common factor, remember the c means it's common to all, so I cannot factor out any y values. How about z's? I get z cubed, and z squared. I can factor out a z squared as that power of z appears in all 3 of those terms. So my GCF is going to be 3xz squared. What's left inside? Well, I'm going to have a trinomial starting with y squared z plus 2yz. And notice, I've taken everything out from this third slot, so I've got to leave a invisible 1 in its wake. And notice if I go to check, this times this is indeed this, that checks. This times this is indeed this, that checks. And if you don't have a plus 1 here, you're not going to be able to, it won't check. 3xz squared times 1 is indeed 3xz squared. So be sure, when you factor out everything from a monomial slot in a polynomial sum, to leave a 1 in its wake, right? Alright, here's one that might stump some students. Factor 9x plus 16. Alright, this cannot be factored further. 9 and 16 have no common factors. They're called relatively prime. And when you cannot factor anything out from a sum, I call it a prime polynomial, or just prime. Our author just says prime would be a satisfactory answer. Alright, prime polynomials, just like prime numbers, can't be broken down into products of smaller integers. Prime polynomials can't be broken up into products of simpler polynomials. Can't be broken down, prime. Alright, the book asks us in a few of the homework problems to factor out some -1 or some opposite type things. Let's see, this one in particular, it says factor a -1 from this trinomial of degree 3. Alright, you can always factor out a 1. You can always factor out a -1 by changing signs. And later on, as we'll see in section 5.7, sometimes it will behoove us, it will profit us to factor out negative quantities rather than positive quantities. So let's get used to it now. If I factor out a -1 from any expression, all I really have to do is change the signs of the polynomials, and clearly we can see that when we check this out, when I multiply this through, I do indeed get what I started with. So my final answer, don't forget to carry down that negative factor, that -1, into your final answer. -1 times n cubed minus n squared plus 8. Alright, here's a type of problem, again dealing with negative type things. The book asks us to factor out a negative greatest common factor from the following expression. Alright, so I've got a binomial of degree 4, And if I look at those coefficients, minus 8 and positive 12, well, clearly I can factor out a 4, but again, they want us to factor out something with a negative sign in front of it, so I'll say the GCF here will be a negative 4 with that condition. And let's see, powers of A, I have at least one power of A common to both. Remember, C in common and GCF means common. And how many powers of B? I've got 2 factors of B, 3 factors of B. I've got 2 factors of B that are common to each term in this binomial. Alright, so I can factor out a 4ab squared or a negative 4ab squared if I play the signs right. Whatever I put in here has to multiply out to be negative 8 squared, negative 8a squared b squared, so I'll put in a 2a. 2a will do it, will it not? Yes. And I want plus here. If I'm factoring out a negative 4, I'll need a negative here. Right? Hang with me. I'm going to factor out a negative 4, so I'll get a negative 3b. Will I not? Let's check it. Minus 4ab squared times 2a is negative 8a squared b squared, and that checks out. And negative 4ab squared times negative 3ab is indeed positive 12ab cubed. So this checks too. Right, so be careful of the signs. Let me write down the final answer a little more neatly. If I factor out a negative GCF, it's a b there, I'll have negative 4a squared, or ab squared, times 2a minus 3b. Alright, 2 more, and I'm going to call it a day. Get a fresh screen. Alright, these are out of your homework list. These are in the upper reaches of your homework list. And if you can handle these, you should be able to handle anything in this section. This is number 93 on page 410. Don't panic. Or maybe we should panic. 3/5 ax to the 4th power plus 1/5 bx squared minus 4/5 ax cubed. Well, I'm hoping everyone out there can see we've got fractions in terms of fifths. Essentially, I'm going to be able to factor out a 1/5 from each of these terms of this polynomial, right? Alright, so let me write down GCF. I don't insist that you write down the GCF separately, but sometimes it helps. Alright, I'm going to be able to factor out a 1/5 from all these coefficients, right? How many powers of A are common to all? Well, there's no A here in the second term, and C means common to all, so I can't factor out any A value. And let's see, x to the 4th. Yes, I've got 4 factors of x here, 2 factors of x here, 3 factors of x here, so I can factor out an x squared. And I believe that's all I can factor out. Can't factor out any A's, can't factor out any B's, because they're not common to all 3 terms. Alright, so let me go ahead and work my distributive law in reverse. 1/5 x squared times, well, if I factor out a 1/5 x squared from this first monomial in the given polynomial, I'll have a 3ax squared, will I not? Plus, if I factor out a 1/5 bx squared from the second term, I'll have only a single factor of b left. And if I factor out a 1/5 x squared from the third slot, I'll have a minus 4. Minus 4. Let's see, minus 4a. Or minus 4ax. Hang on a minute, let me check something. I wrote something down wrong. 93. Yeah, 4a minus 4ax. Okay. Alright, let's check our answer. This one was a little nastier. Let me go to a different color here. Can I check my answer? If I multiply it out, I should get what I started with. 1/5 x squared times 3ax squared gives me 3/5 ax to the fourth. This term checks. Plus 1/5 x squared times b is 1/5 bx squared. That's equivalent, so that's fine. And 1/5 x squared times negative 4ax will give me a minus 4/5 a times x cubed. So that checks also. Final answer, 1/5 x squared times 3ax squared plus b minus 4ax. And a box, right? Alright, one more we'll call it a day. This one's a little nastier too. This is on page 410, number 96. Same page as the last one. We've got a trinomial of degree 21. Don't see too many of those. Alright, well, the numbers get a little high, and maybe it's a little more difficult to pick out the GCF. 54 and minus 90 and plus 72. Can you spot a GCF, or greatest common factor, from all those terms? I think 9. I think I can do better than 9. Certainly 9 is a factor of all. I think 18 is also a factor of all. I can evenly divide 18 in all those coefficients. And remember, you can pull out as many powers of c that are common to all, and every term in this trinomial has at least 19 factors of c. So I can factor out an 18 c to the 19th power. And what remains? Well, let's see. If I take out from this 18 times what is 54? Well, I think 3 will do. And if I take out 19 powers of c, I'll have 2 left in that first slot. Next, let's see. 18, what times 18 is 90, or negative 90? I'll also have negative 5, right? Negative 5, and I'll have 1 factor of c left in this second slot. And if I take out an 18 from 72, that leaves me with a 4. 4 times 18 is 72, right? And if I take out a c to the 19th, that means in this slot I'll have no factors of, hang on a minute. Yeah, so 4 will be our last slot, and this gives us a final answer. 18c to the 19th times the trinomial 3c squared minus 5c plus 4. Alright, so we'll call it a day with section 5.5, greatest common factor type factoring.